Okay, so here's a new problem for us to work on here. Hopefully you're seeing my screen. And let's say I tell you that this leg is 2 and this leg is 4. Do you remember how to find the hypotenuse in a right triangle?
Yeah, a squared plus b squared equals c squared.
That's right. Now sometimes it works out nicely, and this one does not, though. This one requires you to do a bit extra here. So if you
Yeah,
have
you
pencil
gotta
and
do
paper,
16 plus 4, 20, and then I go ahead do 20 times 10, which is 2 and no, yeah, 20, break it into 2 times 10, and then 10 times 5, and it'll be 2 square root 5.
2 squared 5. Good. Okay, and that's very important here. So we're going to start by looking at this angle right here, A, and determining the sine of A. Okay,
Mm-hmm.
the sine of A.
That one is opposite over hypotenuse.
Yes. So what is opposite to A?
4
Okay, over
and 2 to the power of 5.
2 square root of 5.
Yeah.
Okay. Now the problem here is that and I don't know if we've talked about how to reduce these types of roots before or rationalize. But while this is correct, you have to do a few more things to make it like acceptable for your final answer. Okay. So
Mm-hmm.
first thing is like, let's just deal with the 4 over 2. 4 divided
That
by, go ahead.
that would just be 2.
It's 2 over the square root of 5. Now you have to rationalize from here. Rationalizing is to multiply the top and bottom by the square root of 5. So it's 2 square root of 5 over, what is square root of 5
5,
times 5?
just
Okay.
5.
Yeah. And this is like a necessary step here. Like you can't just leave it as 4 over 2 square root of 5.
Okay. All right.
Right. All right, so let's look at now the cosine of A. Cosine of A is the adjacent over the hypotenuse. What does
Mm-hmm.
that become?
2 over 2 out of 5.
Yes. So just like in
And
the
this one
previous
would
problem,
just be 1 a square root of 5 over 5.
yes. Now you kind of jumped ahead there, but that's great. It ends up being the square root of 5 over 5. You would not say the 1 in
Oh,
front.
okay.
You would, I mean, even though it's there now, you would write it as square root of 5 over 5.
Okay.
But let's say I wanted the tangent of A. Tangent of
Uh,
A is
uh, opposite over adjacent.
so 4 over 2, which is just
That would just
2,
be 2.
and that's no big deal. I mean, there's no rationalizing needed.
Yep.
Okay, so let's look at another triangle here. All right, let's say that this is 16 and this is 8. Will you find the missing side here, B, for me,
Yep.
please?
So first I will do 16 times 16 to minus 64. And then I do, see if there's a square root of, and it would be square root 192, which I then will break up into, so then I will break that up, which I will begin to do 192 divided by 2, 96, 96 divided by 2, 48, 48 divided by 2, 24, 24 divided by 2, 12, 12 divided by 2, 6, 6 divided by 2, 3. So it would be, and then I got 6 2s, so I'll be 1, 2, 3, 4, 8, 8 square root 3.
Perfect. Yes, B is 8 square root of 3. Okay. We'll actually be looking at this as one of the special triangles here in a moment. Let's do the same thing here. Let's have you find the sine of A, the cosine of A, and then the tangent of A.
Sine of A would be 8 square root of 3 over 16, right?
So it's 8 square root of 3 over 16, but can you reduce that? I think you said square root of 3 over 8.
Yeah.
Yes.
And then Cosine will be 8/16, which would just be 2.
Try again. Remember it's the top
Oh,
divided by the bottom.
0.5.
1/2, yep.
4, yeah. No. And then it'll be, and then tangent will be 8√3/8, which will just be square root of 3
Good.
over 1.
Or just square root of 3.
Just square root of 3, yeah.
Okay, let's try another one here.
Okay.
10 square root 2 and 10. I'd like you to find B for me, please.
Okay. Well, 100. Find out. Probably choose than I do. 2 times 2 times 2. Oh wait, hold on. And I can break that up into 5 times 2 times 2. 20. I'm actually not sure how to do this one. Can you explain it?
Sure. So 10 squared plus B squared equals 10 square root 2 squared. Now on the right here, notice I've put it in parentheses. Okay.
Mm-hmm.
So you're squaring both the 10 and the square root of 2. 10
Mhm.
squared, and you can even write it that way. 10 squared, square root of 2 squared. 10 squared is 100. Square root of 2 squared is 2. The square undoes the square root. So
Oh,
you've got 100 plus B squared equals
200. So B
200.
would also be 10 then.
Yeah. Okay. So let's do a little bit different here. Let's put well, that wouldn't make any sense. Let's put A at the top here. Let's find the sine of A, or have you find the sine of A, cosine of A, and the tangent of A.
Okay, so first it will be 10 over 10 square root of 2, which would just be square root of 2.
Try again here. It's 10 over 10 square root 2, which the 10 over 10 makes 1.
1.
1 is in the numerator. And you can't leave
Oh.
it like this. You have to rationalize.
Oh, do square root of 2 times, 1, just square root of 2 then, right?
You have to multiply the top and bottom by the square root of 2.
Oh, it would be 2 squared 2 divided by 2.
Yes.
Okay, cosine will be 10. It'll be same thing,
Okay.
square root of 2. And then tangent will just be 1.
Tangent is 10 over 10, which is 1. Good. Okay. Let's have you try one more here. Before we move on to the actual special triangles here. Let's have you try this one here. Let's say it's 6, 10, and let's call this A. So I want 3 values: the sine of A, cosine of A, and the tangent of A.
Okay, all right. Well, I know it would just be 100, 136, and now, all right, 130. All right, and then now I gotta break down 136. So I'll do 136 divided by 2, divided by 2, divided by 2. All right, now I hit 17. So it will be 17 times. So I get 2 times 17 plus square root of 2. Square root of 17 plus square root of 2.
It's got to be there's it's a number on the outside and then a number on the inside of the root.
Yeah. So it'll be 2, right?
Maybe.
It,
So tell me what
because
else.
I got
tell me-
136. I do
Yep.
136 divided by 2, divided by 2, divided by 2, divided by, and then 17 is a prime number.
Okay. Yeah. So, but what is the requirement to bring it out? Like, what allows you to bring it out in this
There has to be a group. There has to be a pair.
a pair in this
So
case?
it would just be 34 on the inside then.
Yes. Okay,
All
good.
right.
Go ahead and reduce.
All right. Cosine 10 over
Do-
2 will be 5
Let's do
over
do sign first. Yeah,
oh,
there's a reason you want to do them in this order. That'll become clear later on.
cosine. Okay. 10 over 234. Reduce that to get 5 over square root of 34. And then I multiply both sides by that. It would be 34 times 5 square root of 34 over 34.
Okay, I agree. Keep going.
Cosine will be 6 over square root of 34 divided by 2. 3 square root of 34 over 34.
Okay,
And then this one would be 10 over 6, which can be simplified to 5 over 3.
5/3. Good. Okay, very good. So let's look at a couple of special triangles here. So there's two special triangles. The first one is a 45, 45, 90 special triangle.
That's the equilateral, right?
No,
Or
no, no. Equilateral would be all sides the same, or it's all sides and all
uh,
angles. That's not this. This is a right triangle where, well, I guess an equilateral is special, but not typically in the context of what you're doing here. So the 45, 45, 90 means that the two base angles are 45, the two sides are congruent, and this is a 90-degree angle here.
mhm.
Now this has very special properties, like it allows you to find all three sides from one side. You actually did one of these earlier. The reference triangle is as follows: x, 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 square root 2. And here's what that means, or here's the takeaway. If you're given a leg to get the hypotenuse, you multiply by the square root of 2 to get the hypotenuse.
Oh,
Okay.
okay.
Now, there's also another part of this, and we'll go give them both to you, and then we'll do some problems.
Mhm.
If you're given the hypotenuse, to get the leg, you divide by the square root of 2,
Okay.
and then both legs are equal.
Okay.
Okay, so here's a very simple example for you. And I'm going to put on all the numbers here. So let's say the legs are 5 and 5. You know that the
It'd be
hypotenuse
5
is
square
5.
root of 2.
Exactly. Okay. And if I give you the
It would just be 12 on
it'd
each
be
side
12 and
then.
12, right? So you're like, well, I got it. That's not hard. Well, you're right. It's not. So let me give you ones that you might see on a quiz or a test here. Let's say this is the hypotenuse is 8. To find the leg, you divide by the square root of 2, but that means you also have to rationalize.
So I need to break it down first.
Um,
To
you have to divide 8
2
by the
square root
square
of
root of
2.
2.
So it'd be 2 square root of 2, right?
How did you come up with that?
Because I'll break 8 down into 4 and then
8's not a,
4.
you're not taking a square root of 8.
Oh, okay. It would just be 8 square root of 2 over 2, which would end up being 4 square root of, I don't know.
So you have to rationalize the top and bottom, rationalize the bottom by multiplying by the square root of 2.
Okay, so it'll
What
be
does the
4
numerator,
square root of 8 square root of 2 over 2.
which is 4 square root of 2. So both legs are 4 square root of 2.
Yeah.
So it's easy when it's already got a square root of 2 in there.
Yeah.
Now here's another scenario. What if I give you that the hypotenuse is 10 square root of 6?
I would have to break it up again,
You'd have
find
to
out what
divide
the
it
main
by
number was.
you'd have to divide it by the square root of 2.
Yeah, so that would give me, I multiply it by each square root of 2, right?
Well, there's a shortcut here that I'm going to show you. So whenever there's two roots, you can actually break down what's inside into a fraction.
Okay, so that'll be
So 10
10
square root
square
of,
root of 3.
and notice there's no bottom there. There's no nothing on the bottom to have to rationalize. So this
Okay.
works out here. Okay.
Right.
So let's go the other way now. Let's say I give you some legs. Let's say I give you 8 square root 5, 8 square root 5. What is C?
I need to multiply it by square root of 2 then,
Okay.
right?
What does that
Which
become
would
when you?
be 8 square root 10.
Yes. And there's nothing to do there. No changes. What if what if it's something like this, where it's 5 square root 2, 5 square root 2. What does the hypotenuse
5
be?
square root 4.
Okay. Do you see anything wrong with the way this is written?
No. Oh, can it be reduced?
Yes. What is the square root
It
of
can be
4?
reduced to 2, so it can just be 10.
Yes.
Okay. Okay.
All right. So you feel like you have that down?
Yeah, I do.
Okay. So the next one we're going to look at is 30, 60, 90 triangles. These are like doubly difficult. Like those maybe didn't seem that difficult, but these do get a lot harder. So in a 30, 60, 90 triangle, 30 degrees is across from the short leg.
Mm-hmm.
60 degrees is across from what's called the long leg. And the hypotenuse is
Mm-hmm.
always the hypotenuse. Okay.
Okay.
So here's the mapping of the reference triangle. The short leg is always x, the hypotenuse is
Mm-hmm.
2x, and the long leg
Mm-hmm.
is x squared 3.
Oh, okay.
So
That's a
from
bit confusing.
yeah, now the best case is when I give you the short leg. Okay, if I give
Mm-hmm.
you the short leg, you double it to find the hypotenuse, multiply it by the square root of 3 to find the long leg.
Uh-huh.
That's the easy case. We'll do a couple of those now.
Mm-hmm.
Okay. All right. So let's say that this is 6. What is B and C?
6 square root 2 and 12.
So short-term memory, it's always troubling. We never have great short-term memory. You're multiplying by the square root of 3.
Oh, 6 square root 3.
6 square root of 3. Okay. Let's try another one here. Let's say I tell you that the short leg is 5 square root 3.
Okay, so the long leg would be 10 square root 3. The hypotenuse would be 10 square root 3.
So they can't be the same. It's definitely 10 square root 3. Okay.
And then the other one would be
You're multiplying by the
5
square root of 3,
square root 9.
which
5 square root
reduces.
9.
What does that be reduced to?
15.
Yes. Very good. Okay. So let's try a couple more here. Let's say I tell you that the short leg is 8 square root 2.
Mm-hmm. Okay, so then I know that one would be 16, hypotenuse 16 square root 2, and then 8 square root 6.
Yes, you got it. Okay. Now the second type of problem is where I give you the hypotenuse.
Mm-hmm.
So if you look at this from the perspective of the hypotenuse, so before, sorry, that's the square root of 3. So before, if I gave you the leg, you could double it or multiply by the square root of 3 right away. But if I give you the
Mm-hmm.
hypotenuse, the only direction you can go is to find the short leg. Like you have to cut it in
Okay.
half. Okay.
Okay.
Then you have to multiply it by the square root of 3. So there's kind of a path that you're forced into. So an example would be, let's say I tell you that the hypotenuse is 15. Okay. What is
I'd
15?
have it would
Yo,
be 12.5.
7.5. I'm sorry
7.5.
about that. That's really bad. It's 15 over 2 or 7.5, right?
Mm-hmm.
And
Yeah,
then you still have to multiply it by the square root of 3 here.
which would be 7.5 square root 3.
Yes. Okay. All right, so let's do a few more here. I'm also not changing the orientation of the triangle, like not rotating at all. That's also another possibility. I'm trying to keep it simple here. Let's say this is 6 square root of 3, and that is the hypotenuse. How do you find the short leg?
I could have
Okay, what is this?
3 square root 3.
Okay, and then to find the long leg, you multiply by the square root of 3. So what does that become?
That would end up being 9. Just
You got it.
flat.
Now, by the way, the whole Pythagorean theorem thing, a squared plus b squared equals c squared, that has to still
Mm-hmm.
hold. Like like that has to still work, and it does.
Okay.
So this on the left here is 3 squared times
Mm-hmm.
3, which is 27,
27.
plus 81. So what is 6 squared
36.
times 3? Is this true?
Yes, it
Yes.
is.
So it still works. Okay. These are just shortcuts here. Okay, so let's try another one
Okay.
here. Let's say I tell you that this is 8 square root of 6. Okay.
Okay, so it'd be 4 square root of 6 on the lower end, and then it would be
Short leg. We want to use the
short leg, yeah.
yes, or
And then
shorter
it would
leg.
be 4 square root of 18 on the long leg.
You want to make any changes to this?
I think I can reduce it to
You can.
be 12 square root 3.
It is 12 square root of 3. It is 12 square root of 2.
2, sorry.
So these are just tiny little things that could be the difference between like an A or a B or full mark and not full mark. So
Okay.
just be
All
as
right.
careful as
Okay.
you can here. Let's say this is the square root of 20. And I want A and B here.
Would the lower end be square root of 10?
You are not allowed to divide inside the square root. Notice in the previous
Okay,
problem,
so
you didn't.
I do 10 times 2, so it'll be 2 square root 5, right?
Yes.
And the lower end would be square root 5, and the upper one would be square root 15.
Good. Okay, so real quick here, just because we don't have a ton of time, just do a quick one here. This is a 45, 45, 90. Let's say this is 14 square root of 6. What is A? What is B?
Okay, since we're doing it by 3, I know that other one would have to be 2, so it'll be 14 square root 2, and then on the short end.
These are 45, 45, 90. These are the same. A and B are the same.
Oh, A and B are the same. Oh, this is a 45, 45,
Yes.
90.
So you will be
Oh,
going back and forth. You've got to be able to do that. So you actually just divide by the square root of
of
2,
2.
which
So
is
that would just be
14.
14 square root 3
And
on
these are
both
the same.
ends.
Very good.
Okay.
All right.
Okay.
We've got a lot done.